So we're dealing with limits at infinity of some kind of rational number. And the tricks are denominator. Hold on. Get my eraser. So the tricks here the tricks here are going to be something that you just kind of want to memorize. I'm going to write them down, and then you guys can pause and write them too. So your shortcuts. So I just wrote them down and have them all ready to go. So the shortcuts of limits at infinity. And we got to make sure we understand what the degree is, what the coefficient is, and what the leading term is. So first, let me just, you guys can write this down. You can pause and write this down. But I want to make sure you understand the difference between each of these vocabulary words. So if I have something like 8x plus 7x to the third plus 2x squared, let's say. The degree of this is whatever the highest power is. So in this case, this is the highest power. So if the degree of this whole thing is 3, if that's higher than, let's say, the degree of whatever's at the bottom, what's the highest thing at the bottom? We'll say 7x plus 9x to the 5th. If the degree is less, this one, the degree is, because the degree is the highest number of that whole expression right there. So it's 5. So if 3 is less than 5, then your answer is going to be 0. Now, if 3 was equal to 5, so, or not 3 was equal to 5, if the degree of the top was equal to the degree of the bottom, well, this is still the degree of the bottom, even though I changed it, because it's the highest degree down here. So that's the degree of the whole thing down here. Since they're equal, then I will just get 0 for an answer. I'm sorry, then I would use the ratio. And that's the next thing that we need to discuss. The ratio of the leading coefficient. Well, that means the ratio of the numbers that are in front of the highest degree. So in this case, 7 is the coefficient in front of the highest degree. That's the leading coefficient. And down here, 9 is the coefficient, is the leading coefficient, because that's the one in front of this degree. So if these two are equal, then I'm just going to get the ratio of those two for an answer. And then finally, if you have we'll keep the 3, and it says if the degree of the numerator is less than or greater than the degree of the denominator, then we're going to work through the leading terms. So in this case, let's just say that was 2. Now, the degree of the numerator, which is 3, and this is still the degree, this term, but it's 2, and that's less than, so that's what this is talking about, is less than the degree of the numerator. So we're just going to work through using only the leading terms. We're just going to consider the leading terms, and we'll work through that. So in this case, we're really just going to find, if this was the limit, as x approaches infinity, I would just end up because the top degree is bigger than the lower degree, I would end up not even trying to figure all of this stuff out. And I would sort of just have this problem that looks like this. And then I would go ahead and deal with the limit as x approaches infinity. So let me just give you some examples. And I'll keep this. We'll keep the shortcuts. Way over here. I'm going to erase all of this. And I got to put the D over here. So I'm going to keep this here where we can look at it. My internet went out, so I'm not sure if I'm repeating this, but in this case, 2 is the degree of the numerator, 3 is the degree of the denominator. So this goes with this one here. The degree of the numerator is less, 2 is less than 3. So your answer is just 0. So let me take you through another example. Say I have 7x squared minus 5x all over, actually, let's make it 14x down here. 14x squared minus 3x. And I'm trying to find the limit as x approaches infinity of this. Well, in this case, I'm going to go, the degree of this one is 2, the degree of this one is also 2, so this is the one we're using. So that means we're only going to use the leading coefficients. So these are the leading terms, but I'm only going to use the leading coefficients for my answer. So that's going to equal 7 over 14, and then I reduce that, which is 1/2. So the limit as x approaches infinity of this is equal to 1/2. And the final type of example that I want to show you is the last kind. And say I have 8x squared minus 5x all over x plus 5. So in this case, the degree here is really 1. The degree of the top is 2 because that's higher than 1 here. And the degree of the bottom is 1 because there's no other x's to compare it to. So in this case, the degree of the numerator is higher than the degree of the denominator. So I'm just going to work through the leading terms, and that's the whole, these are the leading terms. This is a leading term. This is a leading term. Here we just use the leading coefficients. But in this case, we're just, oh, I should say the limit as x approaches infinity. So I'm just working with the leading terms now. So I don't have to, this is x squared minus 5x, I don't know, whatever. So I just have to work with the leading coefficients. So I'm going to come in here, And you know, these aren't the leading coefficients just because they're written first. I probably shouldn't have done it like that. They're the leading or the leading terms because this degree is the highest, it leads in the race to be the highest. So 8x squared over x to the first is all I'm going to really consider. I'm not even going to consider that. And then I'm going to go ahead and simplify this a little bit. And that's going to give me 8x, right? Because that cancels and you have 1x left up here. So now if I take the limit as x approaches infinity of 8x, well, that's kind of like 8, if I'm going into infinity, but 8 times, I'm still into infinity, so my answer is infinity. So basically this skips all that stuff where you got to divide everything and work all that out. We're basically just trying to memorize these things. If they're equal, you get 0. If the top is less, not you get 0, you consider just the ratio of the leading coefficients. If the top is less than the bottom degree, then it's 0. And if the top is more than the bottom degree, then you go to infinity. So just keep these little shortcuts in mind so that you don't have to spend all that time. It does work, and these aren't just rules of thumb, they work. If you have any other questions, please contact your teacher. Be great.